Hey, it's Slynk, and we're back in Max for Live talking about DuckBuddy. And last time we left off looking at the function object, and we were talking about how to use these numbers that come out of here. And we'll get back to that in a sec, but I just want to talk a little bit more about message boxes because I want to make sure it's super clear how they work. So looking back at the routing stuff that we covered last time, you can see I've got this load bang here. We explained how the sends and receives work. So why am I banging this message box? Well, yeah, I thought it would be good to talk about message boxes. First of all, to create one, you push the M key and then I can type stuff into the message box. It could be numbers, it could be words, anything really. And messages travel through these gray cables. Messages do not travel through these dotted line cables. These are for audio signals only. So I can't send the word hello through this signal cable, right? It can only go through these gray cables, but that doesn't mean I can't send numbers through these gray cables as well. I'll create another message box here and connect this one to the second inlet. So you can see it says set the message without output. And then if I use a bang object here and send a bang into the first inlet here, it says right there, trigger the message. So we bang the message and that outputs the contents of the message. That contents goes through this cable and sets this other message to the word message. We can also send the message box a message that says set and then followed by something like hello. And if I put that into the first inlet, now this message has been set to hello. So it was kind of like setting the parameters on the function like we did in last episode. You don't need to bang the message to send the output. You can also just control click it, and that it acts kind of like a button where it like fires the stuff out of there, right? When you click it. So yeah, hopefully that all makes sense. Okay, let's look at the function again. So the main problem we're having now, after we got the points into the curve and we're visualizing it with a live scope, is that we can't adjust the length, the total duration of these points. It's kind of just tied to the X coordinates, right? 1,000. And the way that curve works, you give it one number and then that's the starting position. Then you give it a second number, that's the destination position, and then a length of time in milliseconds. And that's what we're doing here with these numbers. We've got a point to go to and then how long to get there and then the curviness. The next point to go to, how long to get there and the curviness. If we could change this middle number here, then it would get there faster, right? Now you might be thinking, why don't we just use a message to the function object to change the domain? And that is a good idea. Whoops, let's use a message box. Domain, let's try setting it to half, so 500, and we'll just connect that here and control click it. And yeah, that kind of works, but now I can't access these points over here and we still have the same points. It's more about like what I can actually edit in this device. Changing the domain doesn't really work. So we're back to the drawing board. Also in the function object, there's some other options that we might want to use. Down here, we've got the output mode. And if we set this to list and then send it a bang, we actually get the 3 numbers for the very first point, which I think is going to be useful. So we have all 3 points. We have 3 sets of 3 numbers. And I think if we keep things consistent like that, we'll be able to say, hey, just take the second number out of 3 and, divide it by 2 or something. So how do we do that? So what we're looking at here is technically known as a list. It's items separated by a space, right? All in a row. And there's lots of objects in Max for Live that help us handle lists. And you can check them all out by just creating a new object and typing list dot. And there's a bunch of different list handling objects here. You can also just use ZL dot. And it's all the same stuff. It's just a little smaller, right? So what we need is a object that can help us access every second number out of a set of 3. So how do we do that? Well, we have the nth object here, extract item from list. So let's try this out. We'll send the list into that. This is where the list goes. And in this inlet, we need to tell it what number, which item in the list to extract. So we'll go 1, 2, 3, 4, 5. This is really the number we want to access. So let's type a 5 in here and we'll control click that. And then on the outlet side, this is the 5th element that we're going to get. And out of this side, we're going to get the rest of the stuff. So everything but the 5th one. So let's send the list through and see what happens. Okay, that's actually perfect. So this can be pretty handy. We can access the 5th number, then we could, divide it by 2 or something, and then incorporate that number back into the list. And effectively, we're shortening the length. Now, this is all well and good for the 5th number in this list, but we also want this number. So how do we get that one? Well, we could duplicate all of this and put the list into this one and tell this one to get the 8th number. And that does work, but what are we going to do when we have 4 points or 5 points, right? This isn't going to work. So we need a more clever way to do this. What we need is a way to split the original full list up into smaller chunks, into say sets of 3. Then we could tell this nth object to just grab every second number. If we're sending out 3 numbers at a time, it's always going to be the second number that we want, right? And we can do that with the ZL Iter object. So let's look at the help file really quick. The help file is always helpful. It successively outputs lists of a specific size. So if we send it a long list, it will split the list up. And we can tell it that we want lists of 3 to come out of the bottom here. So if we send a list of 9 into it, we'll get 3 lists of 3. And then if we send that into here, we'll get every second number coming out of here. Now, it's only going to show us the last set of how do I even say that? It's only going to show us the last one because it's sending this one, then this one, then this one. So let's have a look at that with the print object, right? Over here in our Max console, you can see first we got the 0, then we got the 537, then we got the 462. So that's doing what we want. That's great. Now we need to edit this number and incorporate it back into the list and recombine it all. Now this object, the ZLNth, has a special property where you can actually replace items in a list instead of just extracting an item. And there's a brief explanation of how to do that in the help file, but I'll explain it for you here. So let's just get an easy list to handle, right? Like dog, cat, bird. If we send that list into here, we can tell this object that the second item in the list, we want to switch to fish. Okay, I didn't spell bird right. Let's put a message box on each so we can see the result. So let's tell it, whatever you get, the second item is going to be fish. Okay, now let's send the list into here. And there we go. The replacement has been successful. And we also get what was originally there coming out of this side. So we can even send this list into this setup to test it out. There we go. The second item in the list is now fish. Okay, so we're getting there, but we don't want it to be fish, that's for sure. So maybe it's time that we talk about the dollar signs. So if I change fish to $1, meaning like the first variable, then I can send this message another message, and that will effectively change what this $1 represents. Right now it represents nothing, but if I send this message, another message, say cat, now the second item will be replaced with cat because we sent cat to this message. And there we go. So we've got, again, we're getting all 3 through the print object. Actually, let's put the print object over here. Yeah, 0 cat, 0. This number cat, 0. That number cat, that number, right? So it's working. It is working. We definitely don't want to be setting it to cat either, but at least we can change what's being set. So imagine we have like a num box here. Now we can set this to any number. And now every second number is coming through as 57. Now that's almost working. That's almost working. What we need to do is take the original number, do math to it, and then insert it back in. Okay, it's all coming together. Okay, here we go. Check this out. I put some labels on things and set things up a little bit more for a test. So we've got our list of 9 numbers that goes into here. Then this thing spits out 3 numbers at a time. So that goes down to here and also this way. When we go this way, we're accessing the second number, and that number is going into this divide object, which we can divide by any number we want because we've got a num box set to that. So now we're able to edit the number somehow. The result of our edits come out here and go into our $ message, telling this one to replace the second number with what we did here, and then print. So let's give it a try. Ta-da! It works. Okay, sweet. So we can just wire that up to the curve, and it doesn't work. And that's because we're sending it 3 lists all at the same time. And it's not really in curve format anymore. We need a list that looks like this, not 3 lists that look like that. So how do we do that? We need to combine all 3 lists of 3 numbers back together into a list of 9. So to combine this list back into a list of 9, we can use the ZL group object, okay? And if we tell it, yeah, we want a list of 9, then when this object gets 9 things, it will send out the list of 9. So we should be able to just wire this up like this and send that into our curve. And let's see what happens. Hey, it actually works. So, and look at that, it's actually 1/4 the length as well. Let's make that 1, so it's the original length. There we go. So that's pretty cool. Now, the only problem with this setup is, what if we add another point? Now there's 4 points, which means there's 12 numbers, and this doesn't work anymore. So what we actually need to do is count how long the list is, and then we can tell this group object to wait for that many numbers, okay? So we'll go ZL len, which gets the list length, len for length. So we'll send the list this way, and this should tell us that we have 12. Yes. So if we send the length into here, and instead of using this 9 here, it will do 12. This should work. And it does. Awesome. Now let's, oh yeah, I gotta actually output the, I'm changing this, but nothing's coming out because we need to bang this. Okay, so let's try this. Yeah, that's working. That's working great. Awesome. So I think we understand lists a lot better now, and I think we're ready to actually take a look at how DuckBuddy is doing it. The B patcher is sending the lists out into this send and receive pair. We get the list here. It goes into this subpatcher, which let's open it up and actually take a look at it. Okay. And you're going to see a lot of the same stuff. So the list comes in here, and we are using this ZL reg, which stores the list so that we can output the list again if we need to. For example, if the length changes, right? Then we have the ZL Iter, which is sending out 3 numbers at a time. We're doing math to the second number. We're combining and replacing again. We've got a group here to group it back together with the length. And I'm also using a couple more objects here to add my own bits into the list to avoid errors, right? If you happen to make a shape that didn't have a point in the top right corner, you might end up stopping here, and then I guess the volume on that channel is just half forever now, you know? So what I'm doing is manually adding another point that's always in the top right, 100. So this is adding it to the end. And I'm using a ZL join to do that. So this, you can see here, the second segment of the list. And this is the first segment of the list. I guess I should explain what this is. This is just a trigger object. It takes a message, and that message is fanned out to multiple outputs. So the list comes in here. Then the list is converted to a bang and goes out here. And then we bang this message and it goes in here saying, hey, that's the second part of the list. Then the original list comes out of this outlet and goes in here. And then the first part is combined with the second part. It goes into here, etc., etc. And eventually we get to the curve. So there's a bit more to explain here. But yeah, I think we've kind of covered most of the list handling stuff. So although it looks pretty complicated when you first look at it, you're like, oh my God, what is all this crazy math and stuff? It's actually not that bad once you kind of understand how all these bits work. And just breaking it down and putting in comments to remember what's happening and making notes for yourself can make it easier, right? So we've got a bit more time in this episode to cover the trigger object a little bit more, and also the join object. I'll use the join object as an example. And I think it's pretty important to get the hang of these trigger objects. So let's say we have a simple list again, dog, cat, fish, and we're using a ZL join to join this list with another list. We'll have another list over here that's, I don't know, cat, bird, okay? And we want to make a list of all of these 5 elements, even though I wrote cat twice, doesn't matter. Now, here's the problem, okay? And this is one quirk with Max. There's different color inlets, okay? And only the red inlets will actually cause the object to do anything or output anything. So right now, nothing has been sent through these cables. So if I send this list, well, that's the list that we got because it hasn't received what it needs to be joined to yet. So if I send this now, well, nothing got outputted. Okay, so you can see the problem where we need to tell the join object what we want to join to it before we give it the thing we want to join to, right? If that makes sense. So that's why we use trigger objects to make sure that we're doing stuff in the correct order. So trigger, T for short, and then we can use, all number of different things, any kind of formats, right? We can output lists, we can output bangs, we can output, numbers. So this trigger object, it will send out the number 1000, then it's gonna bang this light, and it's also gonna set this message to the list that we give it. Let's give it a try. And only some of those things worked. I think this needs to be just an L. Yeah, L for list. So how do we make sure that we do these two things in the right order? We can just use a trigger object to send out 2 bangs. First, it's going to send the bang out of the right outlet because we work right to left. I don't know why in Max for Live, but that's just how it is. So first we're going to bang this one, then we're going to bang this one. So if the trigger object gets triggered with a bang, it's going to bang here. It's going to set what we're joining the list to. Then we're going to send the list into here and it's going to join them. Boom. I'll give you one more example with a plus object. Okay. So if I have a number 2 and another number, let's say 6, and another message box to see what happens. Again, obviously, until I send the 6 to this plus object, the plus object doesn't know what we're plussing it to, right? The 2 comes in here. We're going to plus it to, I don't know, we haven't got anything yet. So just send out the 2. Yeah. But if we send the 6 first, then the 2, we actually have the correct result. Okay. You might be wondering how I even know about all these objects. Is there a list of all objects somewhere? Like how do I know that there's a live numbox, for example? Well, up the top here, there's these lists that you can browse through to check out all the different objects that are available. This one specifically is for Max for Live stuff. So these are all the Max for Live. We got a menu here and you can just click and drag them. This is the numbox. We've got a dial, slider, and you can read what each one does by clicking the green arrow and then going to the help file. And there's always an awesome demonstration on how it all works. And don't forget to check out the different tabs because there's more information on each tab. Now over here on the right, it also gives us a very detailed explanation of what happens, I guess in this case, when we send a bang to the inlet on this live menu. Well, it sends out the current item out of the outlet. Okay. What if we send a number to there? Well, that does something different too. And what if we send a message with the word assign followed by a floating point number that causes, other things to happen. So we get a full list of what happens when it gets certain messages and what happens, what we get out of here and demonstrations. It's really it's really great. The help file is how I learned how to use Max for Live. Basically, I was just curious and started clicking around and learning lots of things from the help menu. So I'd encourage you to give it a try. All right, that'll probably do it for this video. I think we have gone pretty deep on the list action this video, but I'm pretty sure we all have a great understanding now of how these numbers can turn into something that we can visualize as a signal, and that signal can be, multiplied by our incoming signal and change the volume. But there are some more nuances to how this all works. But maybe next time we'll talk about something else. Let me know what you're curious about. I think the next logical step is to talk about the length and how that's calculated according to the sample rate and whether we're using time mode or milliseconds mode. But if you want to look at something else, maybe the scopes or, just let me know in the comments. All right. Thanks for watching. Peace.